Let's start. This is in page number 211, fourth question. Okay. So we have chords AB and CD of a circle with center O. So we have a circle first, and then we have two chords. Let this be CD. Let this be AB. Okay. So we have two chords. And these two chords are intersecting at a point E. So this is going to be the intersecting point. And this is the origin of the circle. Chords AB and CD of a circle with center O intersect at a point E if OE bisect angle AED. OE means this angle, bisect angle AED. Okay, what is the meaning of bisecting? Bisecting means equally dividing, right? So angle AEO will be equal to angle DEO. That is the meaning of bisecting. Okay. Prove that prove that chord AB equal to chord CD. So we need to show that chord AB is equal to chord CD. Understood the question, all of you? So we are given two chords and center of a circle. And these chords are bisecting at some, not bisecting, these chords are intersecting at some point. From the center to that point is actually dividing angle AED equally. Okay. Now, if this is the condition, that is, the condition is OE is dividing angle AED. If that is the condition, then you have to prove that chords are equal chords. Equal chord means the chords are of same length. Okay. Is the question clear? Hello.
Yes, ma'am.
Yes, ma'am.
Okay. So what you need to do here is first, when they are asking you to say chord AB and chord CD are equal, don't you think, see what is the, there is a condition that we have learned about equal chords. When will the chords will be equal? One condition, one specific condition you have learned, which is related with the distance from the center. Anyone remembers that?
The distance from the center is equal.
Distance, yeah, when the distance from the center to the chord are equal,
Is equal
then
for
the
both.
chords, yes, when then the chords will be equal, right? That's what you have learned. So that is the rule, or that is the concept that we are going to use here to prove this. Okay, so the distance means what? Distance is always perpendicular distance from the center. So first what you need to do is draw a perpendicular from O to AB. Okay, from O to AB. Similarly, draw a perpendicular from O to CD also. Okay, so, so what you need to do, you have to draw a perpendicular from, you can write down that as part, draw perpendicular from O to AB, and what did I say? From, okay, from O to AB and from O to CD. Okay, so let's mark those points as M and N because I'm following the same naming convention as in the textbook. Okay, so we have got OM and ON. Fine. So what is it that you have to prove? Prove OM equal to ON. This implies chord AB is equal to chord CD. Understood? So how will we prove OM and ON are equal? We have to use the congruence. Which are the triangles we have to consider for congruence? Can anyone help me with that?
OME and ONE.
OME and ONE, that's correct. So we will write consider triangle OME and triangle ONE. Okay, so here what all things are equal? Angle OME equal to angle ONE equal to 90 degree.
OE is common.
Yes, OE equal to OE because it's common. Then what? Okay, then there is one more angle. No, see in the what is given, angle OEM. Angle OEM is equal to angle OEN is given to you, right? It is saying OE is bisecting angle OED. That is what is given. Angle AED is bisected by OE. So what does that mean? Angle OEM and angle OEN will be same. Basically this angle and this angle are going to be equal. Okay, so when those two angles are equal, don't you think the third angle, which is this angle and this angle, are going to be equal? In a triangle, when two angles are equal, consider two triangles, correspondingly two angles are equal, don't you think third angle also will be equal? I'm not getting a response from Vidat, Eva, Nalin. Are you all understanding?
Yes, ma'am.
Yeah. Okay. So we will write, that means that angle MO, what is it? MOE is equal to angle NOE. Okay. Third angle. Angle will be equal, right? Or you can say when two angles are equal.
Isn't this
Yeah.
4 statements?
Sorry.
Isn't this 4 statements?
There is no 4 statements. The thing is, we want only 3 statements, but how should we select the 3 statements so that it matches to SAS or SSS or RHS, those rules? One of the rule we should get. At the moment, we don't have, do we have anything? Just look at this and tell me. We have RHS, that is angle M. We have this thing, one angle. We have this angle, okay? And we have this. So what is
AAS.
that? AAS, yes, you can consider that as AAS. Then you can stop here, no? We can stop here and say that based on AAS, this is congruent. Okay. But 1 minute, I'm always confused about one thing. I'll just confirm this. Give me one moment. 1 minute.
Done.
Yeah. Okay. So based on AAS, what you have said is two angles and one of the third side, right? Okay. Yeah, you can write it AAS. So we can end up saying that. Yeah, here itself you can say that the triangle. Here you can say that the triangles are equal. Otherwise, what in the textbook what they are doing is they are going here to prove that based on ASA they are equal. That's all. Okay, whatever. That is not very important. So we can just say, if you don't want to write this part, we can just delete it. 1 moment. I'll just delete this. So based on which all triangles are going to be equal, triangle OEM is congruent to triangle OEN by AAS rule. Right? Angle side, yes. Now what is the next thing to do? So when the two sides are equal, when the two triangles are equal, can we write OM equal to ON by CPCTC? Can we say that? Getting me?
Yes.
Yeah, that's all. So by CPCTC, they are equal. So we will just say what? Yeah, OM and ON are equal based on CPCTC. Therefore, code AB equal to code CD. Hence proved. Or if you want, you can write that Chords equidistant from the centers are equal. Chord equidistant from the centers are equal. Please note this down. The next question, fifth one. ABC is an equilateral triangle. So let's first draw ABC. Okay, here it is A, B, C. Now a circle is drawn with center A. Okay, so this is going to be the center of the circle, so that it cuts AB and AC at points M and M. So the circle is like, circle is somewhat like this. So this is cutting at M, this is cutting at N. Okay, now see, you have to understand AM is the radius. Similarly, AN is also radius, just for you to understand, because they have very clearly mentioned A is the center of the circle. Okay, then what? A circle is drawn with center A so that it cuts AB and AC at points M and N respectively. Prove that, what is it? BN equal to CM. We need to prove BN equal to CM. So what is BM? So basically you have to join BN and you have to join CN. So these two, we have to say they are equal. Okay. So this is what you have to prove. Is the question clear to you all? Hello.
Yes, ma'am.
Here. Okay. Now, for this, again, here, what you will do is you take two triangle and you show the congruency, because one side is CM, this side is CM, this side is BN, right? So if you consider two triangle BMC and triangle BMC and BNC, okay, somehow if you show the congruency, you can say that BN and CM are equal. Okay, that's the idea. This is what we are going to do. But for that, what do we need to know? We need to know BM. What is BM or what is CN? We should know that. Okay, we need to know BM and CN. Fine. Now, in an equilateral triangle, what is the speciality of an equilateral triangle? Can you all tell me? What is the
All sides are equal
all the
and angle is 90. 60, 60.
60? Yeah. So we can write in an equilateral triangle, AB is equal to BC is equal to AC, and angle A equal to angle B equal to angle C equal to 60 degree. This is known to you. Now, you also know that AM equal to AN. AM equal to AN. Why? Because they are radii of the same circle. Because of that, these two are equal. AM and AN are equal. Now, tell me, what is AB minus AM? Can I say this is equal to AC minus AN? Can I say this? AB minus AM, AC
Yes, ma'am.
minus AN, right? Because AB and AC,
AB and AC are equal. Same in the
AM
cut.
and AN are equal. Both are equal. Now, when I subtract AM from AB, what is left? What is remaining? What is remaining there?
MB.
MB, right? This is what is remaining in this side, and this is what is remaining.
NC.
Yeah, NC. That's correct. So let's write that way. MB equal to, what is it? NC. Okay. So this information is required to prove the congruency. Okay. Now let's start with the triangles. In triangle BMC and triangle BNC, let's look for the equal things. we can say, we know that CN and DM are equal, right? That is, we just proved MB equal to NC, proved above. Which is the next thing? Can you guys tell me? Anything common? Understood? No, which all triangles?
B.
Yes.
Yeah.
Ma'am, what B is the center point O in the triangle.
There is no center point, right, for a triangle. We are not saying it is center.
Okay.
So
Ma'am, can you
here,
scroll down?
so I have only one point right now. MB and NC are equal. Is there any other point which you can get it from there? Understood or not? Did you get this, Vidat? Gia?
Yes, ma'am.
Ma'am, can you
Shreyas?
scroll down?
Okay.
Yes, ma'am.
So here what you're doing is, okay, have you completed writing? Are you writing it down?
Ma'am,
Yes.
overlapping each other.
Which all are overlapping?
The triangle BMC and BNC.
But still, okay, 1 minute. Can I consider this as one triangle? This is one triangle. Okay, and the other one is light coloring I'm using. This is another triangle. Okay,
So we
this
can
is,
prove
which
that
side is common?
common.
How can you? Yeah, we can, but I have to prove, no, they are congruent. How will I show they are congruent? That's my
BC
question.
is common.
BC, yes, exactly. You have to say BC is common because BC is common. That's it. Common. Now, which is the next thing? So BC you have identified. Now, look at the yellow triangle. In the yellow triangle, I hope you can see that yellow triangle, right? Can you? Yellow triangle, can you all see?
Yes, ma'am.
In the yellow triangle, angle C we are getting in a complete angle C we are getting, right? Full angle C we will get. Only if you consider yellow triangle, we are getting this entire angle. Similarly, when I consider the green triangle, I am getting full angle B. Am I getting it? Are you all understanding what I'm
Yes,
doing?
ma'am.
Yes,
So
ma'am.
this is, both are 60. I mean, when I get full angle, it is 60, that I know, right? So write that also. So angle, how will we write that? Angle, what was it? MBC equal to MBC equal to angle BCN. Angle BCN equal to 60 degree. Okay, angles in an equilateral triangle. Okay, now, so we understood those two triangles BCN, no, MBC and BCN. Fine. Now, can I scroll up? Hello. Are you guys there?
Yes, ma'am.
Yes, ma'am.
I'm going to scroll up now. So which all sides I have equal? So this side and this side are equal, right? This side is equal. And then what? Between those two sides, this angle is equal, right? So can I say this as SAS?
ASA? No, ASA, right?
Oh, this, how is it ASA?
No,
Two-
SAS, SAS.
SAS. Two. We are considering
Sorry.
two sides and one angle, one included angle, right? So two sides and one included angle is what we are considering. This is the included angle, this side and this side. So it is two sides and included angle. That means it is ASA. So this is
I don't understand the difference between ASA and AAS. Like similar ones when there are like two angles in one side.
see, ASA means this is a triangle. Okay. So when you have a triangle like ABC, ASA means A stands for what? Angle. S stands for what? Side. Okay. So if you're talking about this angle and this side, okay, in both the triangle, there should be two triangle, right? For congruency, we should have two triangle. So when we talk about two triangles, two angles are equal. Two angles are equal and the included sides are equal. Then we say based on ASA, they are similar. They are congruent. Understood? This is ASA. Two angles and
Okay.
the side is included between them. In between the angles that you are considering, the side you are considering. Which was the other one you said? ASA and?
AAS.
AAS. AAS, the difference is you have one triangle, two triangles here. A, B, C, D, E, F. You are considering this triangle and this triangle. This one, not this triangle, these two angles are what you're considering. Now, if you say these two are equal, the rule becomes ASA. The rule becomes ASA. So you cannot consider, when you are not equating those sides, okay? If you are equating this side or this side are equal, or if you are equating this side and this side are equal, then we call it angle side. Understood? So it shouldn't be two angle and one side. That side shouldn't be between the two angles. If the two sides that you are considering is lying between the two angles, then that becomes ASC. Understood?
Yes, ma'am.
What if the similar side is down?
What do
On
you
the
mean?
base.
That is also fine. If instead of this side, if you want to consider, okay, instead of this, if you're considering this side and this side, that is also fine. That is also AAS. Just only condition is it cannot be included side. It cannot be this side. That's all. If it is that side, it will become ASA. Understood? Otherwise, both sides are okay. Fine.
Okay.
Yeah. Okay, so we have to write, coming back to our original question, we will, so we have got 3 points here, which shows that triangle BMC is congruent to triangle CNB. So I told you we have to, whenever you name it, you have to follow the proper naming convention. Okay, you cannot randomly write triangle names. I hope you all remember how to name and all that. Okay, this implies what? BN equal to CM, right? By CPCTC. Hence proved. Please note it down. This is not required. Question 6. The line segment joining the midpoints of two parallel chords of a circle passes through the center. Prove it. So we have a circle. Okay. Now we have two chords, and the two chords, the specialty of two chords are they are parallel. Okay. The chords are parallel. So let us draw two chords. They are parallel. Two chords are parallel. This is the center of origin of the circle. Now the line segment joining the midpoints of two parallel chords of a circle passes through the center. So what they are saying is the midpoint of this chord and the midpoint of this chord, okay, they will pass through the center. That is what they are saying. So when you join the midpoint of the chords, they will pass through the center is what they are telling you. Okay, I hope this is clear. Midpoints of two chords, when they join to midpoints of two parallel chords, when you join, it passes through the center. So that's what they have asked you to prove. Okay. So what will you do here? Here, what we need to do some construction. What is that construction? We will mark the midpoints as P and Q. Okay. Let the midpoint of AB be P and midpoint of CD be Q. Here we are not saying AB and CD are equal. Nowhere they have mentioned it. Just that AB and CD are parallel. That's all. Okay. Now you join OP and OQ. Now draw OE parallel to AB and CD. What do you need to do? You have to draw a parallel line, a line parallel to AB and CD. So I will just draw a parallel line OE. OE. So OE is a parallel line parallel to AB and CD. Now, line segment. Now, what is the next thing that we need to do? What all are equal, which are not equal, all that we have to see. Can we consider PQ as a transversal? Hello. Siddharth, Nalin. Can I consider PQ as a transversal?
You can, right?
Yes, because I'm cutting parallel lines, right? I'm cutting 2 or more parallel lines. So I can consider the PQ as transversal. Now, what is what is OPA? Can I consider OPA as a, this is 90 degree. I'll just change the color. This, can I consider it as 90 degree? Can I consider that as can I consider that as 90 degree?
Yeah.
Yeah. So angle OPA and OQC, these two are 90 degree, right? I hope you're all understanding. OPA and OQC are all 90 degree. Why? Because it's a perpendicular. You're drawing a perpendicular, right? So it's a perpendicular from the midpoint. Okay, midpoint to center means it's always a perpendicular. You have learned it. Previous one of the theorem you have learned. Okay, a perpendicular drawn from the center of the circle always bisects a chord. I hope you remember this rule. Okay, so based on that theorem, angle OPA and angle OQC both are 90 degree. Now, OE and AB are parallel, right? OE and I'm saying, see, I'll just write down all the points again. Angle OPA is equal to angle OQC equal to 90 degree. Why? Perpendicular from the center of the circle bisects the chord. Bisect means equally dividing the chord. Okay, this is the reason. Next is, you know, OE is parallel to AB. What is when OE is parallel to AB? What will be angle POE? Hello?
It's equal to
Huh.
it's equal to angle
90 degree.
OPA.
Yes, it is 90 degree, same as that of angle OPA. Why? Because it is alternate angle.
Yes, sir.
Yeah. So these are alternate angles. So we are considering PQ as a transversal. So we can easily consider PQ as a transversal. So these are alternate angle, consider it. Now next is to the bottom. I'm saying OE is parallel to CD. So when OE is parallel to CD, and we can say and OQ is transversal. Okay. OQ is the transversal. Basically, PQ is the transversal. Here, above I can write and OP is the transversal. Now OE
What is transversal?
transversal means when you have two lines, two parallel lines, even if it is not parallel, we call it transversal. Okay. When two parallel lines are cut by another straight line.
Oh, okay.
This line is called transversal. This I think you have learned in 6th or 7th.
Yeah.
Yeah, that's transversal. Okay. And parallel, I am specifically talking about parallel lines because only if transversal is on a parallel line, we have alternate angle and co-interior angles and all that stuff comes only if this and this are parallel. Otherwise, we cannot say those alternate angles are equal and all. Understood. So that's why we call generally, even though we say transversal, when we say transversal, it's generally we say it in the context of parallel line. But if you have two lines like this and there is a line cutting that, even that is a transversal. But this is a transversal, but here this and this are not same. That is the only difference. Okay, it is also called transversal, but the alternate angles are not same. Co-interior angles are not same. There is no equal corresponding angles, so nothing is same. That's the only difference. Only when two parallel lines cut, when two parallel lines, there is a transversal goes, at that time we have alternate angles and all that concept coming in. Okay. I hope this is clear. Okay. Yeah. Now OE is parallel to CD and OQ is a transversal. Now this, what does it give me? Angle, angle POE. Okay. Here it will be QOE, right? QOE is equal to this angle, okay? This angle QOE and angle what? OQC equal to 90 degree. Again, this is also alternate angles. Fine. So we have got angle POE and angle QA written. So this is written. Now what? What is angle POQ? Entire angle POQ. Angle POQ means this entire thing, is it not? POQ. So
And
what would you
180.
write? Yes. So you will write angle POE plus EOQ. Angle POE plus angle EOQ equal to EOQ or QOE. Okay, whatever. So this is 90 plus 90. So POE is here. QOE is here. So 90 plus 90 is 180 degree. What does it mean? Therefore, POQ is a straight line. Okay. And hence proved you can write. Okay. So because O is the center, right? O is a center. So this is the reason. So anyone has any question? All of you understood or not? So what are we doing here? We are just, we just draw a parallel line OE, the line which is parallel to AB and CD, and considering OP as one transversal and OQ as another transversal. Okay, OP is one transversal, OQ is another transversal. So using, if OP is one transversal, we are saying the alternate angle, this angle and this angle are going to be equal. And otherwise, we say the other two angles are equal. And we just look at what is angle POQ. Angle POQ, we get 180 degree, and that's a straight line. Okay, so please note it down as well. See, I told you this, when we did this problem, we have taken the parallel chords on either side of the origin of the center of the circle, right? Now, if I am drawing both the parallel chords on the same side, then also this is same. Okay, then also the rule remains the same. It will pass through the center. Okay, the line joining the two midpoints of two parallel lines or two parallel chords will pass through the origin. So this rule is applicable whether the parallel chords are either side of the origin or if the parallel chords are on the same side of the origin. The rule remains the same. Okay. Now we'll do one more problem, which is the 7th question. AB and CD are two equal chords of a circle. Okay, so you have a circle, you have AB, you have CD. Okay, so AB is here, CD is here. Fine. As always, center is here. AB and CD are two equal chords. Equal chord means what? AB equal to CD. AB and CD are two equal chords of a circle with center O. AB and CD, on being produced, meet at a point P outside the circle. So you are going to extend these two chords. When you extend, it meets at a point P, which is outside the circle. Prove that. What all you need to prove? Prove that PA equal to PC and PB equal to PD. This is what you are asked to prove. Okay, let's try that. A question is clear to all of you? Did you all understand the question? Please go through the question once again.
Yes, ma'am.
Okay. So here, this I can do by first I'm going to draw a perpendicular from O to AB and to CD. Okay. So what is it that I need to do? Draw perpendicular OM to AB and ON to CD. Okay, so first we will draw two perpendicular. So when you draw perpendicular, this is 90 degree, this is 90 degree. Okay, now join OP. Fine. Join OP. So this is the construction that we are doing to perform this problem. Now PA equal to PC is one thing, and we have to do PB equal to PD, right? Okay, let's do them. Don't you think AM, what is the relation between, okay, I have not drawn AM, N. What is the relation between AM and BM? What is the relation between, can I write AB is equal to half of AM equal to half of BM? Can I write like this? Is this correct? Can I write like this? If I'm writing, why am I writing like this? Eva, can you tell me what I have written is correct or not?
Yes, because
Hmm.
half of AB is MB.
Half of
AM.
AB equal to M. Half of AB is MB. Why? What is the rule? Do you remember the theorem?
Because it's it bisects the line, or it's a
Yeah.
perpendicular from the radius.
A perpendicular from the origin bisects the chord. Okay, that's the reason. Perpendicular from the origin bisects the chord. Okay, similarly, we can write CD equal to half of C. No. What am I writing? It's not correct. 1 minute. It's actually half of AB. It is not half of AM. Okay, CN equal to DN. Understood? Know where I went from? Half of AB is AM. It can't be, half of AM is AB. That's wrong. AB is double the size of AM or double the size of BM. Gia, Nalin, Shreya, are you with me?
Yes, ma'am.
Yes, ma'am.
Okay, so this is something which you should be knowing. Now, what does that mean? They have very clearly told they are equal codes, right? In the question, look at the first statement is they are two equal codes. When two equal codes means what? AB is equal to CD. Okay, that means AM equal to BM equal to CN equal to DN. Correct? Are you all understanding?
Yes, ma'am.
Given that codes are equal. Okay, so that is good enough. Now, what are we going to do next? We are going to find the similarity. Similarity between what? Not similarity, sorry, congruence. Congruence between two triangles. Which are the two triangles? Which are the two triangles we are looking for?
Ma'am,
Which
triangle POM and PNO.
Yes, POM and PON. We can do that, right? So let's start. Consider triangle POM and triangle PON. So here we know that what all we know, OM equal to ON. It is equal codes. Equal codes. Not equal codes. Actually, OM equal to equal codes has equidistant. Not as is equidistant from the center. I hope these rules are all clear to you. This is a theorem. OM equal to ON means equal codes are equidistant from the center. Not is, R you can write. Now, what is angle OMP and angle ONP? Both are 90 degree because they are perpendicular. Okay, OMP, I've already drawn OMP and ONP. Both are 90 degree. Write that. Now, center line OP equal to OP, which is common. So based on which rule they are going to be equal? Which all, see, we
Yes,
have, yeah, we have triangle OMP congruent to triangle ONP based on what? We have a right angle triangle, okay? And the hypotenuse of both the triangle are this side. Both the triangles hypotenuse is OP. So RHS, which is one side, this is another side. So based on right angle, hypotenuse, and one side. Right angle, hypotenuse, and one side. Based on RHS rule, they are congruent. Okay. So based on RHS, they are congruent. So we can write that PM equal to PN. How? By CPCTC. Fine. I hope this is clear. So PM and PN are what? PM and PN are equal, right? By CPCTC, both the sides are going to be equal. Now we need to prove one by one, which is the first part. We need to prove PA is equal to PB. How will we prove that? We know PM equal to PN. We also know that AM equal to CN, right? So AM and CN are equal. Now, if I add PM plus AM and PN plus CN, are they equal or not? They will give me what? When I am adding PM, and are you understanding what I'm writing here? See, look at this. So PM and PN are equal. Okay. So when this is equal as per CPCTC. Now, when I add this side, AM, we know AM and CN are also equal. Now, if I add to PM, I add AM. To PN, I add CN. Don't you think I'm getting PA and PC? Shreya? Do you agree, Shreya?
Yes, ma'am.
Yes, ma'am.
Yeah. So based on that, I can write PA. This implies that PA equal to PB.
PB.
Not PB, sorry. I'm sorry. This is PC, okay? Not PB. This is PC. PA and PC are equal. Okay, because that is the
Ma'am, how?
endpoint. PA, 1 minute. So look at this figure. PM and PN. Can you see this PM and PN green color I have highlighted? They are equal by CPCTC.
Ma'am.
Okay. Now I'm adding AM and CN to PM and PN. So when I add AM to PM, I get entire AP. When I add PN to CN, I get entire PC. So that's how I get PA is equal to PC. Got it?
Okay, ma'am.
Yeah. Now let's do the next thing. And at the end, I'll give you the time to write down the answer. To prove, I need to do PB is equal to PD. It's the same concept, PB and PD. How will I do? We'll start with the same thing. PM equal to PN. Similarly, we know BM equal to DN. Now I'm going to subtract PM minus BM equal to PN minus DN. Okay, PM minus BN and PN minus DN. Let me go ahead and show you this with a different color. So I have PM here, PN here. Okay, PM and PN. Now I know that, what do I know? This length, oh, 1 minute, 1 minute. I am going to pick up another color. Okay, so if I tell you this length, okay, this length and this length is same, right? So I have PM equal to PN from, I know BM is equal to DN also, right? Are you understanding this? PM and PN are equal. Similarly, BM and DN are equal. Are you getting me? Yes, no? What is the doubt here?
No doubt.
So I'm just subtracting PM minus BM. So if I cut this part, what do I get? I get only PB. Similarly, if I cut this part, DN from the PN, if I'm removing PN minus DN, what do I get? PB equal to PD. So I'm showing again they are equal. So here I can write this will become PB equal to PD. Hence proved. That's all. Okay, please write it down.